Right, this is the plus or minus 12 volts, minus 10 volt supply we pulled out of the MDS in the previous video. Sitting on my nice new bench, so it doesn't wobble about like it did in the previous video. So sorry about that. It was made for Intel by a company called Power One. I don't think they even exist anymore. And unfortunately, there doesn't appear to be any schematics, and unless anyone out there knows different. This one luckily doesn't seem to be that complicated. The 5 volt one, I can't really figure out what the hell is going on with that one, but luckily there isn't a fault on the 5 volt. This one, as we know, the plus 12 volt doesn't work, and I've checked it and it definitely doesn't. I'll have a little point out so you can sort of see roughly how it's put together. We've got a stonking great transformer here. There's two centre tapped windings. This lot do the plus supplies and this lot do the negative supplies. They go to a sort of classic 2 diode 4-wave rectifier. If you look here, this is on the negative side, you can probably see the 2 diodes there. The ones to the positive one are over here, and they're underneath these wires, which unfortunately are quite stiff, and I can't move them out of the way for you. The output of the 4-wave rectifier goes onto these 2 large reservoir capacitors, and that forms the unregulated supply. Looking at it, it seems to be something like this drawing here. This is a off a stock data sheet for the LM723 regulator, and it's something similar to this. It's not identical. We've still got this resistor here, and we've got the LM723 driving a big transistor which controls the current, and in that way the output voltage. These resistors here are slightly different. This is actually a variable resistor, so you can adjust the voltage on our circuit. If you look at we go back to the actual device, this is the LM723 here, and the big power transistor is actually behind here. I'll show you that in a minute, but you can see the bolts here and here, and the base and the emitter for the transistor are here and here, and that's repeated another couple of times. So we've got over here, we've got the one for the negative 12, down here we've got the one for the negative 10, and again we've got the 2 LM723s, and the adjustments, these are the negative ones, and this is the positive one. Supply itself seems to be split into 2 halves, the positive half and the negative half, and it's sort of, there's 2 grounds. If you look down the bottom here, there's a ground for the negative and a ground for the positive. As far as I can tell, there's no actual electrical connection between the 2 halves of the supply. I'm not quite sure why. The 2 sides of it aren't completely identical. The positive side is just as I described from the data sheet there. The negative side is slightly different. If you look carefully, we've got these little 2 transistors here and here, and they seem to be a sort of Darlington arrangement into the main power transistor. So that's the sort of overview of what I know so far anyway. I had a bit of a probe round. Both of the unregulated supplies are absolutely fine, and the negative regulated supplies are fine. What isn't working is the regulated plus 12 volt. This could be for a number of reasons. My best guess at this stage is probably the LM723. And if we go back to the circuit again, when I sort of probe about, there's very little voltage between the base and the emitter. Certainly not enough to turn the transistor on, and obviously if the transistor doesn't turn on, we'll get no current flow down here, and hence it's not going to be able to control the voltage in the load. The problem with it is that this board, all of the traces are actually on the other side of the board, so I can't actually see them. I've started sort of drawing a schematic here, but unfortunately I haven't got very far, as you can see, because I really, it's going to take me forever to figure out, what's actually on there. So what I'm going to have to do, I'm going to have to remove this board to do anything, basically. The problem is that this board is mounted on top of the 3 power transistors, which I'll show you in a minute. And the way it's been done is really awkward as well. I think this one here is the most obvious to show you. If you look either side of this diode, you see there's 2 pins sticking through the board. That's the base and the emitter to the TO3 form transistor here. Now that one, and that one, which are the 3 transistors, is the only thing that's holding this on, well, other than obviously the bolts through the transistors. And I'm going to have to be really careful, because somehow I've got to unsolder these without destroying the components around them. If I'm sure you can't see it on the camera, but if you look really closely, when they put this thing together, that there's sort of soldering smoke marks on a few of the components, and some sort of horrible crusty flux. So it's going to be pretty tricky. I'm not going to try this on camera. I'm going to do this off camera, because if I'm not careful, I'm going to destroy this board, and that'll be the end of it, basically. My plan is I'm going to re-tin the base and the emitter connections, put a bit of flux on them, then I'm going to use a vacuum desoldering gun, which I've got here, and hopefully draw all that solder out and then remove them. But I think it's going to be a fairly tricky job. Let me just turn it over so you can see the transistors. There you go. That's the transistors on the other side. You can see here, this was the bolts we could see coming through from the other side. You'll also note, if you can just see it glinting, they've all got mica washers on them. Obviously that's quite important, because the metal case is actually the collector of the transistor, and these are all going to be at different voltages, so if they were all bolted to this metal case, it would be a complete disaster. It looks, if you sort of peer, I mean, I'm sure you're never going to be able to see this, but if you sort of peer down here, where the bolts go through, it looks like there's some sort of plastic inserts. One thing I'm not particularly happy about is, you might be able to see this board isn't sort of laying off to one side. They've not even clipped the component legs, and they're virtually touching the metal case, or this end is. This end's quite high up, so it doesn't really matter, but this end's terrible. If I bend that down, that resistor there would actually touch the case, which is shocking, really. So at the very least, I'm going to have to trim those component legs off. I suspect what's happened, when it was new, it was probably absolutely fine. It was probably all at the same height of this side, but what's happened over time, the board's warped, and it's sort of laying down in this corner. I don't know if it goes all the way back. I think it does, actually. I think it's sort of laying at an angle, so it's sort of, if I hold my pen up, it's that sort of angle. The only weird thing there is about it that I've found so far is down the bottom here. There's a couple of SCRs, silicon controlled rectifiers. Sorry, I don't know what they're doing, which is a bit worrying, but we'll find out when we get the board out, no doubt. They could be some sort of old over voltage crowbar. I don't know what else they could be, to be honest, because in a DC circuit, it's pretty much like a switch. Once you trigger it, it's going to be on. It won't go off again, short of pulsing a negative pulse into it anyway. So I'm going to try and get the board out now. When I come back, we'll have a look, see what the other side of the board looks like, assuming there's anything left by that point. Right, okay. Right, got the board out. Wasn't too much of a drama. This little capacitor here got a little bit singed at the bottom. I can easily change that. I don't think it's actually damaged the capacitor itself. The plastic's missing now though. The only problem was, if we look at the other side of the board, there's a huge quantity of solder on this. I presume it's been sort of flow soldered in a bath or something. If you look at where I've had to desolder it from the other side, it's really deep. So effectively you have to suck all the solder up that little hole. So a couple of them did take a couple of attempts, but it's all come out, and as far as I can tell, nothing's been damaged. You can see now, if I get the right angle, this is the plus 12 volt supply on the top here, and that's the minus 12, minus 10, and you can see it's actually sort of physically split across where I've got my pen. There's no sort of connection between the two. That's that. Did notice something. When was it? Oh, I think somewhere around here. Looks like someone had a problem originally, and they've had to sort of scrape away the solder. You can see the sort of marks. Just an interesting little thing there. I've redone the circuit. Let me get out of the way. Looks a bit of a mess, unfortunately. It's the trouble when you're trying to sort of sketch something out and test it at the same time, but it's much as what I thought, really. You can see the rectifier up in this corner here. Any interesting thing I did notice is that the LM723 has got its own little power supply. It's if you look here, it comes off there, around there, through that diode. And a little capacitor there, so it's got its own little half-wave rectified power supply that goes into there. Other than that, everything in the circuit seems okay. So at this stage I'm sort of fairly convinced that it's the LM723 that's the problem. I'll show you how I check the transistor. Right, here's my circa 1980 transistor tester here. If I find the transistor wherever it's gone. Oh, here we go. Right, so I'll clip that onto the collector and that one onto the emitter. The idea is that you probably can't see it, but there's a little LED there flashing away. Now when I touch this on the base, the two should flash together. Right, there we go. Yeah, you should just better, hopefully you can see it. Let me turn it around a bit. Maybe it's better at that angle. There you go. You should just better see that LED on the top there flashing away. So that proves the transistor's okay. The other thing that I said about the SCRs on the bottom of the board, that is what they are, crowbars. You can see it here on my rather rough looking circuit. It just literally just short circuits the supply. Let me show you a better drawing. This is a much better drawing that I've got off the internet of a crowbar circuit, and it's exactly the same as our one. Well, it's not quite the same. Our wire here is actually on the other side for some reason. So all that happens is this is our power supply voltage across here. This the worst possible case, of course, is this transistor might go short, at which point the unregulated, say sort of 18 volt supply is going to get all the way through here to where it should be 12 volt, which should obviously be fairly catastrophic. So what happens with this circuit is we've got a fuse here and a Zener diode here, and this Zener diode is selected, so it just starts to conduct when the supply voltage gets to a sort of reasonably dangerous level. I don't know what yet. We'll have to find. I can't get the figures off the Zener because the voltage is on the other side and I can't see it. But basically, once the Zener starts to conduct, it drives power into the gate on the SCR. That turns the SCR on, which creates a completely dead short across the unregulated supply and blows the fuse. So that's how it works. So got to make sure you got a downstream fuse, otherwise it's going to make a rather a mess. Right, let me just set up and then we'll try and desolder the 723. Right, all set up, ready to go. I've put a little bit of flux on these top 4 pins, so we'll give those a go first. Right, run around. Blimey, it looks like I've done 2 in one go there. That was interesting. Right, let's go for this one. Oh, amazing. So it's done the other one as well. That was effective, wasn't it? Right, what I usually tend to do is just sort of flick the pins a bit. And you can tell then if they're actually free. I might have to redo that other one there. I think the bonus ones, I don't think have gone all the way, but that's how it's done anyway. That's the desoldering gun that I'm using. Right, I'll carry on do the other joints and then we'll see how we go a bit later on. Right, I've got the 723 changed now, and lo and behold we have our 12 volt back, which hopefully you can see on the meter here. These little pins that are all over the place, I'm just wedging the emitter and base connections because obviously I don't want to solder them back at this stage. That's the remains of the 723, and we're using that one again. What I did notice though is that the date code, batch code on the other 723s are all identical, so what I'm going to do is try and change those as well while I've got it out, because they might potentially fail as well. I'll show you the other voltages. Let's move these over to the ground. Right, that's the -12 and that's the -10, so everything's working now anyway. I did have a quick look at the reference manual, and the reason there's only 2 SCRs on here, the -12 hasn't got a crowbar on it, so and they don't sound that brilliant, to be honest. The ratings on the -10 was it will trigger at -13 plus or minus a volt, so I'm not sure I'm that impressed on the safety of that, but there you go. Right, so one thing I didn't show you is the little insulators that are underneath the transistors. Hopefully you can just see that. That's what stops the pins and the bolts actually touching the aluminium frame. Right, I think that'll do it for this one. Hopefully next time you see this it will be back in its case. So we'll see you next time.